for part 3 Intro to Algebra. Dito naman, pagdidiscuss natin ang mga additional definitions of terms and other techniques na ginagamit natin for algebra. So let's start. First definition natin, factorial. Factorial is denoted by n. N is a number, okay? N is a number. N, exclamation point. Itong exclamation point ang nagsasabi kung bakit siya factorial. Represents the product of all positive integers from 1 to n inclusive. N, ibig sabihin ng n is to the infinity. Basta positive number siya, integer. So, makikita natin siya ganito. N is where 1 times 2 times 3 times 4 times 5 times to kung anong number man itong n na to. So basically, factorial is just a sequence, type of sequencing siya. So pag sinabi natin, examples niya, 0 exclamation point or 0 factorial. 0 factorial is 1. This is a rule. This is a rule. Next is 1 exclamation point, 1 factorial. So 1 factorial is 1 because this is n. 1 is n. So i-multiply natin si n, which is 1. That's it. Next is 2 factorial. 2 factorial, i-multiply natin si 2 times 1 or 1 para mas madali. 1 times 2 which is equal to 2. Kasi diba? 1, ano bang susunod kay 1? 2, which is n. That's why it's 2 factorial. So 3 naman. 3 factorial is 1 times 2 times 3. 1, 3 times 2 times 1. Mas prefer kung sinisimulan sa pinakamalaki up until the last number, which is 1. Ang last number is 1, hindi 0. Kasi pag naging 0 ang last number, automatic na 0 yan. Kaya hindi siya ganun. So, laging last number is 1 from the first number, which is equivalent to n, which is 3. So, i-multiply mo lang yan. 3 times 2 times 1, which is 6. Next, 4 factorial. 4 factorial. 4 times 3 times 2 times 1, 24. 5 factorial. 5 times 4 times 3 times 2 times 1. So, 5 times 4, it's 20. 20 times 3, that's 60. And 60 times 2, that's 120. 120 times 1, that's 120. Okay. Next is identifying the number of significant figures. Okay? So, significant figures, it is each of the digits of a number that are used to express it to the required degree of accuracy, starting from the first non-zero digit. Okay. So, i-explain ko sa inyo kung paano ginagamit to is sa mga problem sa math, of course, magsasabi sila na, okay, since naka-decimal places yung ang sagot, sabihin niya, okay, gusto ko 4 significant figures ang final answers, for example. So, ang gagawin natin is, we need to identify how many significant figures ang kailangan natin to give the answer to the questions. So, may mga specific rules na kinakailangan natin na sundin para ma-identify natin how many sig figs or significant figures ang kailangan. Ito, for example, 0.00003400. So, instantly, masasabi ko na this number has 4 significant figures, which is itong parte na to. Bakit ko nasabi yan? First rule, pag ang whole number or yung number na nasa before yung decimal point is 0, this means na hindi siya significant figure. Hindi siya significant. So, hindi siya kino-considered. After naman, ang decimal, Pag 0 pa din, ang sumunod na number after ng decimal, pag 0 pa din ang sumunod na number, knowing na ang number before the decimal is still 0, hindi siya kinoconsidered pa rin. So, 0.0000, itong limang to, hindi siya considered na significant figures. However, ang unang number na magsimula na hindi non-zero, or mga numbers, 1, 2, 3, 4, after the decimal point is considered significant. So, itong 3, 4 are significant. Pero, this is where it gets tricky. Kasi yung mga 0 na sumunod, pagkatapos ng non-zero, sila ay kinoconsidered na significant na din. Kaya, itong number na to has 4 significant figures. Okay. Ibigay pa tayo ng example. 1.325. This has, sa tingin niyo, ilang significant figures? 4 significant figures pa din. Bakit? Kasi, ang unang number before the decimal is significant. So, automatic. Pag ang unang number unang number before the decimal has a value, hindi siya non-zero. Hindi siya non-zero. Ibig sabihin, lahat ng sumunod is significant. So, pag sinabi natin 1.002, 4 significant figures pa din yan. Kasi, kinoconsider natin lahat significant. Kasi nga, yung unang number before the decimal is non-zero. Tingnan mo dito, oh. Hindi natin to kinonsidered kasi 0 yung nasa simula. Pag sinabi natin 5.20, ilang significant figures to? Diba sinabi ko? Pag whole number, anything, sumunod, are significant. 3 sig figs. Pag sinabi naman natin 0.123, 3 significant figures. Kasi, yung sumunod is 0. Is not a non-zero. So, 1. Diyan tayo magsisimula. Pag sinabi natin 0.002, katulad dito, not significant, not significant. So, it has 1 sig fig. Diba? Pag sinabi natin 0.0020, 2 sig figs yan. Basically, ganun lang naman siya. Another example is pi. Diba? Pi is 3.14. Kung ano pang sumunod dyan. This, ayun. Diba ang pi, alam natin, is madaming numbers yan pag i-search mo sa calculator. Hindi ko kabisado yan. So, pag sinabi ng teacher, for example, kung ano man sumunod, for example, give me the value of pi using 3 significant figures. So, kukunin mo lang yung 3 significant figures ng pi, which is 3.14, for example. Ganon yung pinaka-basic kung saan ginagamit ang significant figures. Next, a form of approximation. So, may dalawang klase tayong uri ng approximation. Una is rounding, which means of replacing the number with another number having fewer significant decimal digits or for integer numbers, fewer value carrying non-zero digits. Okay, so yung explanation niya napaka not clear in my opinion. Pero ang ibig sabihin lang yan, i-round off lang natin yung number. So, pag sinabi natin, for example, 2,106, round off natin siya, makakuha tayo ng 2,110. Kasi, i-round off natin yung tens niya. Normally yung ginagawa dyan, round off to the nearest tens, hundreds, thousands. Diba ganyan? Ones. Sorry. Ones, tens, hundreds, then thousands. Diba? So, basically, ganun lang naman siya. So, pag sinasabi ito, round off this value. So, 2,106.7 magiging 2,001. I-round off natin to. Tapos, i-add natin siya sa 6. So, magiging 2,107. Diba normally, pag may in-order tayo, for example, may in-order tayo sa Shopee. At sa Shopee, 149 pesos yan. Pag tinanong tayo, magkano yung sa Shopee? 149. Diba? Normally, i-round off natin siya. So, instead na sabihin natin 149, diba sinasabi natin 150 pesos yun? Kasi malapit siya. Mas malapit naman yung 9 sa 50. 49 sa 50. Parang ganun lang siya. So, ang pinaka-rule niya lang is i-round off mo, for example, 2,106. I-round off mo lang yan pag yung number na to is greater than 5. So, pag sinabi na 103, 2103, ang round off sa kanya is 2,100. So, basically, ganun lang siya. To know more about rounding off, I suggest na mag-look pa kayo sa YouTube kasi meron pang mga ibang videos kung saan in-explain nila yung kasi ito lang pinaka-basic niya. So, may mga ibang rounding off where sinasabi na round off to the nearest tens, hundreds, thousands, as well as round it off to the nearest tenths as in tenths, hundreds, diba? Hundreds, tama ba? Basta ganun. So, more on ganun lang yung form of approximation when it comes to rounding off. Next form of approximation is truncation. So, ang truncation lang naman sabi niya is refers to dropping of the next digit in order to obtain the degree of accuracy beyond the need of practical calculations. So, para dito lang naman sinasabi niya na for example, you need to do truncations on the nearest 3 decimals. So, from 3.1451415 truncate to 3 decimal place. So, ang kukunin lang natin is yung first 3 decimals. So, sinabi natin, hindi to rounding off. So, kahit hindi rounding off ang truncation. So, ibig sabihin nun na ika-cut lang natin. Tatanggalin lang natin siya. So, from 3.1415, magiging 3.141 siya. So, we just dropped off the number completely. Next. 2.1234. Truncated to 2 decimal places. So, kukunin natin yung first 2 decimal. So, magiging 2.12. Ganun lang siya. Ganun lang kasimple. Walang rounding off na nangyayari. They are different kinds of approximation. Excuse me. Next one is proportion. Hindi naman siya types of approximation. This is another type terms and definition. So, ang proportion naman is a statement that two ratios are equal. So, pwede nating sabihin, instead of saying 2 over 6. Pwede nating sabihin na 1 over 3 siya. So, paano ba natin nakuha yung 1 over 3 from 2 over 6? Ang dali lang yan. So, magsabi kayo ng number kung saan pag dinivide nyo yung number na pag dinivide nyo siya solely from the numerator and the denominator, it will still give a whole number. Pwede ba 1? Pwedeng 1. Pero hindi siya magbabago. Naging 2 over 6 pa din siya. However, ang 2, pag divide natin ang numerator by 2, magbibigay siya ng whole number, which is 1. 2 divided by 2 is 1. And 6 divided by 2, which is 3. That's why we can see that 2 over 6 is equal to 1 over 3. And 3, pwede ba natin i-divide ang 3? Kay 6, pwede. Pero kay 2, it won't give a whole number. That's why ito na ang pinaka-lowest term niya. The way we can also use proportion is, for example, on this question. 100 meter sprint. For example, ikaw, tumakbo ka ng 100 meters in 30 seconds. Sa tingin mo, nung naka 10 meters ka natakbo, ilang seconds kaya yon? So, to solve this, pwede tayong gumawa ng fraction or proportion. So, proportionality. So, sabi natin na 100 meters, 30 seconds yung ginawa yan, di ba? So, equals to, paano naman pag 30 meters, ilang seconds kaya siya? Ganyan lang yan. So, pag napapansin nyo, pwede naman i-interchange tong dalawang numbers. Pero dapat ang rule is, pag nasa taas, in one side, if the numerator is in meters, dapat yung sa other side ng solution mo, dapat numerator is meters din. Tingnan mo, para sila ng unit. Meters, seconds. So, paano natin isi-solve? I-cross multiply natin yan. So, ang magiging itsura niyan is 10 meters times s, for example, equals to 10 meters times 30 seconds. Okay? Pabayaan natin yung signs, ay yung units. So, 10 times 30, ano yan? 300, di ba? 300. So, meron tayo ditong unknown, which is s. So, 100, s, and 300 equals to 300. To solve this, ang gagawin natin is we divide both sides by 100 para ma-cancel natin to. Kasi 100 divided by 100 is 1. Pero pag ginawa natin siya in one side, dapat gawin din natin siya in the other side. Kaya, dinivide natin yung other side of the equation by 100. So, 300 divided by 100. So, cancel natin yan. 3. So, ibig sabihin, 3 seconds, after 3 seconds, naka 10 meters pala siya. So, in 100 meters, 30 seconds. Ganun, that's one of the most basic things na ginagamit si proportion. And with additional of cross multiplication, which is, and division of both sides. So, ginagamit lang dito na nag-start yung idea of algebra. Kasi sa algebra, we find answers kung saan we are given givens, katulad yan, 10 meters, 30 seconds, 10 meters, 100 meters pala, sorry. And to solve, ano yung hinahanap nating solutions. Okay. Next naman natin is LCM. So what is LCM? So LCM is also called as least common multiple. So it's the lowest multiple of two or more numbers. So normally, ang ginagawa lang naman dito is, for example, mga questions is find the LCM of 4, 6, and 8. So, paano ba natin isa-solve yan? Ito ang pinaka-solution ko dyan. So, first of all, let's do 4. So, sa 4, ang 4, alam naman natin, it is 2 times 2. Magkakakuha tayo ng 4. So, aside from 2 times 2, ano pa ba yung other numbers na pag minultiply natin is 4? 1 times 4, di ba? However, the essence of this method is na kailangan gagawa tayo ng branch. Hanapin natin yung 2 multiples niya of numbers kung saan dun tayo titigil. Hindi na natin siya iba-branch out pa. Kaya pa ba natin tong i-branch out? Oo, 1 times 2. Pero, useless na din siya. Kasi, iba-branch out ulit natin yung 2. So, we stop at 2 times 2. Ako, ang ginagawa ko lagi, pag even number siya, nag-start ako lagi, 2. Laging 2 ang ginagamit ko. For odd naman, 3. Kung hindi ka ng 3, next number. Try natin na 6. 6, i-divide natin 2 numbers na nagbibigay ng 6. So, as I said before, start with 2. So, naglagay ako ng 2. Ano pa bang number pag minultiply siya by 2, magbibigay ng 6? Is 3. So, ano pa bang other numbers na pwede natin siyang i-branch out? Wala na. Ganun lang yun. Next, number 8. 8, divide natin 2 numbers na if i-multiply natin, magkaka-8 tayo. Start with 2. 2. Ano pa bang other number? 4. Di ba? 2 times 4 is 8. Pero itong 4, pwede natin siyang i-branch out ulit. So, 2 times 2. Ganun lang yan. Importante natin to find LCM. So, meron na tayong 2. After getting yung mga ending niya, itong mga to, pwede na tayo gumawa ng table. So, ganito. Yan. So, 4, isusulat lang natin. 2 times 2. Kinuha lang natin dyan. Next, 6. 2 times 3. So, ito, may space dito kasi ihihilera natin lahat ng mga same numbers. Kita nyo? Yung 3, wala siyang kapareha. Kaya mag-isa siya. Ang 8. 2 times 2 times 2. Diba? So, ayos. May isa tayong number na lahat sila pare-pareho, which is 2. Next, just bring them down. Gawa kayo ng tables. Ganyan yun. That hile-hile. Nakahile-hilera siya. So, 2. 3, 2. So, 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. That's why ang LCM natin is 24. Aside sa method na to, meron naman tayong isa pang method, which is yung kukunin natin yung sa multiplication table natin siya kukunin. So, 4, 8, 12, 16, 20, 24. 6. Ano ba yung numbers kung saan dapat lahat sila may kapareho? Yung pinakamababa. Kaya nga, lowest multiple eh. That's why 24, 24, 24. That's how you get 24 LCM. Para sa mga small numbers, yung it method na to, I do prefer. Pero paano na pag yung mga multiples niya 1,000, 1,200, 759, diba? So, may hirapan na tayo. Kaya, in my opinion, it depends on ano yung question or yung question kung saan mo siya i-apply. Sometimes mas mabilis to, sometimes mas efficient to. Next, GCF. So, greatest common factor. So, si greatest common factor naman is the largest positive integer that divides evenly into all numbers with zero remainder. So, daan lang tayo sa example. So, mga questions dito is find GCF of 36 and 44. So, ang first step to find the GCF is to find the LCM first. So, katulad nga kanina sinabi ko, find yung LCM niya. So, gumawa na ako ng branch. So, 36, 3 times 12. 3, hindi na natin siya pwedeng i-branch out. 12, pwede natin siya branch out. 3 times 4. 4, pwede pa natin siyang i-branch out. 2 times 2. And 4 times 11, hindi na natin pwede. So, stop. 4, 2 times 2. Kanina sinabi ko na kailangan ako magsimula ako sa 2. However, pag yung mga, alam ko namang mga numbers na, alam mo yun, mas mataas na alam kong, mas mapapabilis mas mapapaunti yung branching ko, ginagamit ko na yan. Pwede din naman natin i-start from 2, for example. So, 36, di ba? Sinabi natin 2. So, 2. Ano ba ang other number pag minultiply natin ng 2? Magbibigay tayo ng 36. To find that, 36 divided by 2. 1, 2, 12, 16, 16, 8, 16, 0. So, 18. Diba? 18, 2 times 9. 9, 3 times 3. So, meron tayong 2, 2, 3, 3. Diba? Eh, diba same lang naman yun? 3, 3, 2, 2. So, kanya-kanya strategy na lang din yan. Next is 4. 44. Same din. So, meron tayong ito, yung mga tumigil na. Diba? So, after finding this, gawa pa rin tayo ng table. Diba? Katulad ng table kanina. Ayan. So, sa table na to, 2 times 2 times 3 times 3. So, 2, 2, 3, 3. Next, 2, 2 times 11. Ihilera natin lahat ng mga same, di ba? So, 2, 2 times 3 times 3 times 11. So, ang LCM niya is 396. Pero ang tinatanong is GCF. So, to find GCF, kukunin natin lahat ng merong kapareho. Dapat lahat ng numbers may kapareho. Sa 36 and 34, dalawang beses na nagkaparehas ang 2. So, 2, 2. May iba pa ba? 3? Wala naman. May 3 sa 36, wala sa 44. May 11 sa 44, wala sa 36. Diba? So, kukunin natin yung 2 times 2 na yan. That's why ang GCF is 2 times 2, which is equal to 4. Ganun lang yan. Okay. Next naman is LCD. Kay LCD is the least common denominator. So, ang least common denominator, para lang siyang LCM. Pero, nagfo-focus tayo sa denominator. Di ba ang denominator is yung babang number ng fraction. So, ito. Find the LCD of the following. 1/2, 1/3, and 3/4. Note, LCD is the same as LCM. Yung sabi ko. Therefore, yung steps on how to solve LCM is the same as LCD. Just focus on the denominator. So, kunin lang natin yung 2, 3, 4. So, ayan. Branch out natin siya. 2 times 1, 3 times 1, 2 times 2. Table. Diba? Tapos, 2, 2. Baba. Bring down. Hilera. 3, 2. So, ang LCD niya is 2 times 3 times 2. So, 12. That's why ang LCD is 12 din. Additional lang, sa GCF, itong question na to, may kahilera siya. Lahat ng numbers niya may magkapareho, di ba? However, pag tinry mo na i-branch out to, pero walang numbers na nagkahilera, nagkapare-parehos sa lahat ng numbers na binigay, ibig sabihin, yung problem na yun has no GCF. Ganun lang yun. Okay, thank you.